Hello. So this is lesson 6.5, determinants and Cramer's rule. So first, we're going to go ahead and define the determinant of a 2 times 2 or 2 by 2 matrix. So the determinant of matrix is denoted by, so it looks like this. So as you can see, the matrix has the elements A1, A2, B1, and B2. The determinant has the same elements. It's just switched from the brackets to the straight lines. And now we can actually calculate the determinant. So if it is A1, B1, A2, A2, B2, what we're going to do is we're multiplying A1 times B2 and subtracting A2 B1 from it. So we also say that the value of the second order determinant is whatever, the value we get, A1 B2 A2 or minus A2 B1. Okay, so let's look at an example here. We're evaluating the determinant of the following matrix. So first we're going to rewrite it 10, 9, 6, 5 with the straight lines. And now we're going to go ahead and do the multiplications. So 10 times 5 minus 6 times 9. So we get 50 minus 54 equals negative 4. Okay, let's look at another one. We have 4, 3, negative 5, and negative 8, and we're evaluating it. So it's 4 times negative 8 minus negative 5 times 3. So we get negative 32 plus 15, and that is negative 17. Okay, where do we use this? We use it to solve a linear system in two variables using determinants. So we're going to use what's called Cramer's rule. So if we have two linear systems with two variables, then we know that our x is going to be this and our y is going to be this. Now, how do we get there? We're first gonna do D, so the determinant, that is A1, A2, B1, B2. Now, so what we did here is we took the coefficients of A and B and put them in a determinant. Now, if we do that for d of x, that means that we're actually going to start with C1 and C2. So that's going to be our first column here. And then since it is x, we're going to take the coefficients of b. So B1, B2. And then if we do d sub y, again, we're going to take the coefficients of a, which are on the left, so that's going to be our first column. And then we're going to take the constants C1 and C2 here. Okay, when we want to calculate x, that would be d sub x divided by d, and our y would be d sub y divided by d, and d does not equal 0. Okay, so let's go ahead and look at solving a problem with this. We're first going to solve the determinant d, which means that we are taking the coefficients of x, so 5 and 3, and coefficients of y, 4 and negative 6. and calculating. 5 times negative 6 minus 3 times 4. We get negative 42. Okay, let's next calculate d sub x. So again, when we're calculating that, we're first going to take the constants, 12 and 24, and then the coefficients of y. So 4 and negative 6. 12 times negative 6 minus 24 times 4 gives us negative 168. Okay, let's do d sub y here. For d sub y, we're going to do the coefficients of x, 5, 3 on the first column, and then the constant, 12 and 24 on the second. So 5 times 24 minus 3 times 12, which ends up being 84. Okay, now we can calculate x and y. So x is d sub x over d. Our d is negative 2. It is not a 0. We have to remember that that cannot be a 0. And our d of x is negative 168. So when we do this division, we get 4. For y, we are using d of y, which is 84, and dividing that by d, which is negative 42, and 84 divided by negative 42 is a negative 2. So our answer for this question is going to be 4, negative 2. So it's these two. Okay, yeah. So this is just another way of solving a linear system in two variables. Now we're going to go into a little bit more complex. With this, we're still using Cramer's rule, but now we're going to go and do the determinant of 3 by 3 matrix. So with this, we need the determinant to be 2 by 2 for us to do the calculation. So what we do is we take that first row here, or first column here, sorry, A1, A2, and A3, and as you can see, we've got A1, A2, and A3 that we're multiplying by. Now, when we have A1, we are taking B2, B3, C2, and C3 with A1. With A2, we're taking B1, C1, and B3, C3. And with A3, we're taking B1, B2, C1, and C2. And we are switching the sign. So the second one is a subtraction, third one is an addition. Now, if we want to do the whole thing, it would look like this. That requires quite a bit of memorization. I feel like this is an easier way to kind of do it step by step. Okay, so our step by step is each of the 3 terms in the definition contains 2 factors, a numerical factor and a second order determinant. Then second, the numerical factor in each term is an element from the first column of the third order determinant, so A1, A2, and A3. The minus sign precedes the second term right here, and for the second order determinant that appears in each term is obtained by crossing out the row and the column containing the numerical factor. So the minor of an element is the determinant that remains after deleting the row and column of that element. For this reason, we call this method expansion of minors. All right, let's get an example here. So we want to evaluate this. So we are starting, well, first we should write it as a determinant. So 2, -5, -4, 1, 6, 3, 7, 0, 1 with the straight lines. Okay, so we're going to take first element A1. So that is 2. That goes outside. Now, the second order determinant is going to be, so we're crossing out basically the row and the column where the 2 is. So we get 6, 0, 3, 1, and close it. Now, when we do the next one, we're going to be subtracting. We're taking element A2, which is -5 to the front, and notice that, yes, there are 2 negative signs here. And then we are crossing out the row and the column where -5 is. So we get 1, 7, 3, and 1. Next one is an addition, and we're taking the A3 element, which is -4, and I'm running out of space here. I don't like this. So I'm just going to write it down here. Plus, and now again, we're crossing out the row and the column where that -4 is, which reminds me that that needs to be a negative here. So we're taking 1, 7, 6, and 0. Okay, now we're going to start calculating the determinant. Our first one is going to be 2 times 6 times 1 inside parentheses minus 3 times 0. Next one, we have a minus and a minus, so plus 5. Oops, I didn't close the parentheses here. Plus 5, and the determinant is going to be 1 times 1 minus 3 times 7. And our third one, positive and negative, that is going to change into a negative. I'm sorry, I've got something in my throat. I'm going to cough. Okay. And then we've got 1 times 0 minus 6 times 7 and close parentheses. Where's my 4? I missed my 4. There we go. Okay, next we're going to do what's inside the parentheses. So 2 times 6 plus 5 times -20 minus minus 4 times -42. So we get 12 minus 100 plus 168. And when we add these, we get 80. So see how much actually, yeah, faster this is to kind of evaluate these. So this was evaluating the determinant of a 3 by 3 matrix. Now we're going to look at solving systems of linear equations in 3 variables using the determinants. So Cramer's rule here. Again, our x is going to be d sub x divided by d, y is going to be d sub y divided by d, and z is going to be d sub d divided by d, where d cannot equal 0. And here are our 4 third order determinants. So d, these are coefficients of the variables x, y, and z. D sub x, replace x coefficients in d with constants on the right of the 3 equations. And then d sub y, replace y coefficients in d with the constants on the right of the 3 equations. D sub z, replace z coefficients in d with constants on the right of 3 equations. So we are replacing whatever, like d sub z. So we're replacing the x coefficients. Sub y, we're replacing the y. Z, we're replacing the z coefficients by the constant. Okay, so let's go ahead and do this step by step to solve this linear equation here. So we're first going to write the D determinant. So that is with the x, or we're actually going to set up all the determinants. Our first one is the D, and that is all the coefficients of x, y, and z. So 3, 2, 1 are the coefficients of x's. Negative 2, 3, and 4 are the coefficients of y's, and 1, negative 1, and 3 are the coefficients of z's. Okay, next one is going to be d sub x. So it should look exactly like what we've got here, except that coefficients of x are going to be different. So coefficients of x are going to be replaced by the constants. So 16, negative 9, and 2. Now, the second and third column should look exactly like they do in D. Coefficients of y and coefficients of z. Okay, next one is going to be the d sub y. And now, again, the first column and the third column is going to look exactly like the determinant D. We're not switching out either one of those. We're switching out the y, the second column, with the constants. So 16, negative 9, and 2. Then we've got one more. We've got z. So again, the first two columns is going to be the exact same as we've got in the determinant. It's the z coefficients that we are replacing with the constants, 16, negative 9, and 2. Okay, step 2 is going to be evaluating the four determinants. And then we're going to substitute these four values and solve the system. So we're going to start with D here. So the same thing what we did already. We're taking the first element, 3, outside, and then we're setting up a second order determinant with these two. So excluding the row and the column where the 3 is. So 3, 4, negative 1, and 3. Next, we're subtracting. 2 is the second row, first column. And we are taking the other rows. We're excluding the row and the column where the 2 is. So it's going to be negative 2, 1, 4, and 3. We are adding, and our third element in row 1 is going to be 1. And again, we're excluding the row and the column where the 1 is. So we get negative 2, 1, 3, and negative 1. Okay, now 3 times 3 minus 4 times negative 1, close parentheses, negative 2, negative 2 times 3 minus 4 times 1 plus 1, negative 2 times negative 1 minus 3 times 1. Just the same way we did with the all the others, we are kind of like, it's almost like cross multiplying. Okay, so we get 3 times 13 minus 2 times negative 10 plus 1 times negative 1. So 39 plus 20 minus 1 equals 58. So that is our D. This is our D. Now we're actually going to need more room here to calculate the D of x, and so we're going to do D of x. I'm going to rewrite the determinant here just so that we have a visual of it. It's easier. Negative 1, 2, 4, and 3. So 16 cross out the row and the column that 16 is on, and we get 3, negative 1, 4, and 3, minus negative 9, and we're crossing out the row and the column where negative 9 is, negative 2, 1, 4, and 3, and plus 2, crossing out the column where and the row where the 2 is, negative 2, 1, 3, and negative 1. Okay, and then um, sitting up 3 times 3 minus 4 times negative 1 plus 9, because there's two negatives, negative 2 times 3 minus 4 times 1 plus 2, negative 2 times negative 1 minus 3 times 1. Okay, and when we do this calculation, we get 116. So this is d of x. Next, d of y, same thing, 3, 2, 1, 16, negative 9, 2, 1, negative 1, 3. These were already written up over here. And we're going to go ahead and take the 3 and then exclude the column in the row where the 3 is, negative 9, 2, negative 1, and 3. Subtract, taking the next one, which is 2, and excluding the row and the column where the 2 is, 16, 1, 2, and 3, plus 1, excluding the row and the column where the 1 is, 16, 1, negative 9, negative 1. Okay, when we do all the calculations, we get negative 174 for d of y. Z was 3, 2, 1, negative 2, 3, 4, 16, negative 9, and 2. So 3 times 3, 4, negative 9, 2, minus 2, negative 2, 16, 4, and 2, plus 1 times negative 2, 16, 3, and negative 9. Oops, that should be a straight line. And when we do the calculation, we get 232. Okay, now we're going to go back to our step 3, which says that we should be substituting these 4 values and solving the system. So x is d of x over d, which d of x, we got 116, and d is the 58. So we get 2. Y is going to be d of y divided by d dy. We got negative 174. We are dividing that by our d, which is 58. So we get negative 3. And z is dz divided by d. dz is 232 divided by d is 58. So z is 4. So now we've got 2, negative 3, and 4. 2, negative 3, and 4 is our order triple. So yes, this takes work as well, but at the same time, sometimes it might be a little bit easier than actually doing the solving, you know, a linear system with 3 variables and 3 equations in the ways that we've done it in the past. Okay, next we're going to look at the determinant of any n by n matrix. So the determinant of a matrix with n rows and n columns is said to be nth order determinant. The value of an nth order determinant, n is greater than 2, can be found in terms of determinants of order n minus 1. So the minor of the element A sub ij is the determinant obtained by deleting the ith and jth column in the given array of numbers. The cofactor of the element aij is negative 1 to the power of I plus j times the minor of aij. Okay, let's see what this means. So we are evaluating the determinant of this following matrix. So it's a 4 by 4 matrix. So what we're going to do here is the cofactor of the element is negative 1 to the power of I plus j. If so, what we're going to do is we're going to go ahead and choose 5 as our minor. So what do we have? So we have we'll have 5 as the one that's outside. Now our determinant 3 by 3 determinant is going to be, we're crossing out the row and the column where the 5 is. And we end up with 0, 4, negative 3 in the first row, 1, negative 2, 6 in the second, and 3, 0, and 1 in the third. Now what we need is the cofactor, negative 1 to the power of I plus j. So negative 1, I is the ith row, 1, 2, 5 is in row 2, plus j is the jth column, 1, 2, and 3, it's the third column, 3. Now, I'm going to do the negative 1 to the power of 2 plus 3. This is the same thing as negative 1 to the power of 5, which we get a negative 1. So negative 1 times 5 is going to be a negative 5. And then we have our determinant. And now we know what to do. We're going to solve the 3 by 3 determinant just like we've done. And when we solve it, we get negative 5 times 50, which is negative 250. And that would be our answer for this one. Okay, let me know if you've got any questions. That's it for this lesson. Bye.